Hey everybody, it's your boy Tin Man here with another Let's Code video. Today we're doing Leetcode problem 486, a medium. Predict the winner. Look at this bad boy, 1,562 upvotes and only 90 downvotes, those haters. All right, let's read the problem. Given an array of scores that are non-negative integers, period. These are always so poorly written. It's not even a sentence. Player 1 picks one of the numbers from either end of the array, followed by the player 2, and then player 1, and so on. Okay, so they alternate turns. Each time a player picks a number, that number will not be available for the next player. Okay. This continues until all the scores have been chosen. Wait, so they're always picking from the end? The player with the maximum score wins. Okay. Given an array of scores, predict whether player 1 is the winner. You can assume each player plays to maximize his score. Okay. So it's not from the end. So here we go. Let's take an example. 152. The output is false. What? Explanation. Initially, player 1 can choose between 1 and 2. Oh, from the ends. Got it. If he chooses 2, so he's going to go maximize it, or 1, then player 2 can choose 1 and 5. Right, 1 or 2 and 5. So if player 2 chooses 5, then player 1 will be left with 1 or 2. So the final score of player 1 is 1 plus 2, which is 3, and player 2 is 5, so player 2 wins, so player 1 didn't, and that's why it's false. Hence, player 1 will never be the winner, and you need to return false. Oh, snap. So, this is like a tree or something, right, of choices. So here's one that's not just 3. So 1, 5... 233 and 7. So random. So whoever picks this one basically so player 1 is screwed. Unless he picks 1. Right? Okay, so he has to pick 1, thereby screwing player 2. And then player 2, no matter what he picks, then player 1 picks this one and he's done for the day. So let's see what it says. Player 1 first chooses 1, then player 2 have to choose between 5 and between 5 and 7. No matter which number player 2 choose, player 1 can choose 233. Finally, player 1 has more score than player 2, so you need to return true, representing player 1 can win. All right, constraints are the length of the array is less than 20. These are small arrays. Any scores in the given array are non-negative. Cool. And they won't exceed 10 million. Awesome. If the score of both players are equal, player 1 is still the winner. Ha! I still won. All right. So let's draw this one out. How the heck are we going to do this? So, let's see. Let me do a line here. And, let's see. Oops. Hold on. Oops. Let's just draw an array. We don't have to make it that big. Okay. Whoops. Let's do another line. Hold on. Okay. That's enough with the line. Just drawing out like an array here, nice and neat. So we can draw stuff. Gotta start getting whoa, what the heck? Start getting an idea of what we're gonna do. So, all right, good enough. One's a little, maybe space it out a little bit more. There we go, good enough. All right, so back to pencil mode. All right, so maybe change the color. Let's make it some purple. Yeah, nice and fancy. All right, so let's see. Let's pick that harder example. What was it? It was well, let's stick to the easy one. What was the easy one again? 1, 5, and 2. So 1, 5, and 2. So let me get an arrow. We got an arrow right here, yeah. Okay, good enough. Back to pencil. Pointer. So we're here. We're player 1. We could either get 2 or we could get 1. But we're kind of screwed. So like as player 1, I mean. So let's see. Let me pick another color. I'll get red. All right. So we could either do 1 or we could either do 2. And if we do 1, let's say we use an object and we have 1, some value, and then 2, some value. Those are our 2 choices that we can pick. So if we were to pick 1, the other player would be 5, and then we would pick. We could do scores like this. We could have a little scores array for each choice, and see if we win or lose. I don't know. I'm just thinking of the data structure to hold like our selections. It's small enough that we don't have to get anything fancy. They said something like all of like this would at most be like 20 slots. So we could probably just have like things in an array. Like actually we could just have an array where this is like 0, 1, 2, and maybe like pick choices here like that. And let's just conceptualize it. So let's see. So if we're taking the first turn, player 1 always takes the first turn, right? I think, given player 1 picks one of the numbers. Yeah, so player 1 goes first. Let's see. So 1. So if he picks 1, for example, you know, and if he picked 2, and then we can play it off like that. What's going to happen, though, is like, what about in a longer array? Like this. What if it were like 1, 5, 2, 4, 3. Let's go all out. 8. Is it always even? The score array. No, it's not always even because the first one was like 3 numbers. So let's say this. Let's play this out. So player 1, he would either pick 1 or 7, right? 1 or 7. Then player 2. Player 2, if 1 had been picked, then he would pick 7 or 5, right? 7 or 5. Oh man, all right. So then player 1 again. It's like this combination is 1 or 7, and then it's like if I picked 1, isn't it like it's always like these 2 choices? And then for each one of these, it's like 2 choices. And then each one of these is like a score. Oh, man. It's right. So if you get to the bottom, I meant to have 2 there. Like, not like that. Like they're like that. That means like then you'd have to like go all the way back up and give the score here to see if you're beating. Yeah, it would be like a representation like that, where you're going down the entire length of the tree to calculate like something, the score. So, so this is also kind of like this is not a greedy algorithm. This is like dynamic programming. So basically, you just have to you don't have to use a tree. We could use an array. Let's keep it like how long would the array be though? Like for something that's of size 3, let's see, it's either let's try and represent this one 1, 5, 2 because it's kind of like the easy case. So player 1 can choose 1 or 2. If player 1 chose 1, then you're left with 5 and 2, and player 2 could either choose 5 or 2. And then that's kind of like the end of the game. Well, if you choose 5, player 1, let's see, let's think about this. If you choose, then it's going to be like 2. And player 1's score is, so this is player 2. Player 1's score would be 3. And they'd be losing because like player 2 has 5 versus 3. But if it's this way, well, that's dumb. Player 2 would choose 2 because then that would be 5, and player 1 would win. But player 2 would never choose like 2. Like, that's silly. Like, he would choose 5. So he's always going to pick the maximum. So at every turn, oh, you know what? At every turn, you're just, so it's I think I got it. So you're having a for loop, right, across the array, and for every one, you're just picking the max between 2 numbers. That's it. Oh, except for this case, though, right? Like where you try and mess them up. So here you, like not in this case, but in that second case where you have, what was it? 1, 5. Remember this one? 1, 5. 233 and 7. In this array, it's kind of like strategic. You would pick the minimum here as player 1 in order to mess this guy up. So you get that. So then he has to pick 5, and then you pick this one. So, ooh, that's a tricky case. I don't know how we would do that. How would you actually do that? I don't know. That's a tricky one. I mean, I don't see any way to do it other than like you kind of have to do all of them and just see which one is the maximum. Right. So basically you're doing that tree that we talked about here, right? And you have to like bust this out and then just pick. By the time you get here, you kind of go all the way up and then fill in the score there. All you care about is whether you could win or not. Yeah. So. Okay. I'm thinking whether we can try implementing this. Just go ahead and implement it and use, I guess, some kind of like recursion to see if you've reached a base case. So I'm just thinking, what would be the base case? Like picking the winner of whatever the current condition is. All right, let's try. I don't know. Let's try to do this. How would we do that? So let's see. So you're given like the array. So what you basically want to do, so you want to return who's the winner, right? Of the array. I'm just going to write a function. Setting it up. Winner. How do you, like here? So how do you know like player 1? Let's see. Const. Like what if you had a winner between player 1 and 2 that took whatever the array was. Can we? Do we have to pass the array? I'm wondering. Like, is it gonna change? We're not gonna alter it. Right. So we don't need to pass the array. So the array's right there. Oh, yeah, what do we need to pass it? We need to pass it like the beginning number and the end number in that array, right? Oh no, yeah, we have to pass the array because you know what? It's going to keep changing based on, well, we're going to slice off like part, either the beginning or the end, right? So we'll pass an array. We'll pass it like kind of like the start value and the end value. And I guess like what iteration we're up to, or the tree length, or I guess, yeah, like the depth. What do you want to call it? Like the turn? Call it the turn. Wait, what am I doing? Const equal to, okay, that was fat arrow. So I guess here we could just do 0. It starts at 0 and goes to num's length minus 1, right? And we're on the first turn, right? And we want to see who the winner is. Or actually, we want to see. And let's see. Well, so let's work on our function first. So the function is recursive, so we need the base case, right? The base case is going to be if start is equal to end. I mean, then we're just done, right? So we can return. What are we returning? The start, right? Is it the start? Num start times the turns. Is that right? Times the turn. Otherwise, we're gonna have to recurse and pick either what happens in this case or what happens in the other case. I got it. I think I got it. Oh, I think I got it. Okay, so let's have like int. Oh, what am I talking about? Let's have let n1 and n. Let n. No, it's confusing. It's like two parallel worlds. Like what ifs. All right, let's just do A and B. Let A equals to the turn times nums start plus winner total recursion. Nums start plus 1 end negative turn. Let B equal to turn times nums end plus winner nums start and minus 1. Am I doing this right? Minus turn. And then if we have these two made up numbers, we can just return turn times the maximum of whichever is like the bigger one. Turn times A or turn times B. want to know here, actually, if this is greater than or equal to 0. If this even runs. Okay. This could just be by chance that this worked. I don't even know if this is right. All right, let's just submit it and see what happens. 50-50 chance. What? Really? I didn't even use this. Okay. So it worked. Okay. All right. Well, I'm shocked because I thought I messed up with the start and the end. And so just iterating through here and just keeping track just worked out. All right. So this has been Leetcode. Problem number, what was it? 486, a medium. And yeah, that's how it went. So yeah, cool. All right, thanks for watching.